Alrighty, good. Go ahead and continue. On problem 14, let's do one of these. I think B, it's a little difficult. So let's try B. 14B looks like this. So when you have absolute value of something, it can either be a positive or absolute value of -5, for example, it's also positive, right? So we need to make sure we account for that. So when we take care of the absolute value, we're going to have two problems. We're going to have this one. So this is one of the problems. When we take the absolute value, this is our second problem that we'll have. All right, we just need to solve both of these in a very similar manner. We're going to set it equal to 0, move it to the right. So if I subtract x, I'm going to get minus 19x. And then I'm going to add 18 factor. Or you could use the quadratic formula. I think in this case for me, factoring is easier, quicker. So factors of 18, that when you add, you get -19, is -18 and -1. Multiply those, you get positive 18. Add them, you get -19. Set them equal to 0. You're going to get these solutions. So we're going to do essentially the same thing over here on this other problem. It's going to look slightly different. That's a plus, right? When we distribute the minus sign. I'm going to move now, since the x squared is negative, I'm going to move them to the right. Set it equal to 0, now to the right. And then I'm going to subtract 18x. And this is what I get. Set it equal to 0. And again, all we have to do is factor. What are factors of -18? That when I add, I get -17. -18 times +1 gives you -18. Add -18 plus 1, you get -17. Nice. Set them equal to 0. And you get these two solutions. All right, so we got three different ones, right? Because this one and, well, x equals 18 are the same. We don't have to include both. These are your three answers that you get. You have to check each of them back in here into the original problem. Plug them in for x. And you're going to figure out that when you check 18, plug 18 in here, in here, this is going to be equal to 0. This is going to give you 0, so that checks out. Okay, so you're going to do the same for all of your solutions to check. Make sure they are correct. And it turns out that this one doesn't work. And this one does work. So this is not a solution, right? Since it doesn't work. Let's go ahead, I guess, and try it. Let's put in a 1 in here. So 1 minus 18 is -17. The absolute value of -17 gives you 17. 1 minus 18 times 1 gives you -18. 1 minus 18 gives you -17. 17 is not equal to -17, and that's why x equals 1 does not work. And then you check the -1, and that one works, okay? So that's how you do this problem here. You guys can try the other ones. So let's go ahead and do 15. To maximize profit, how many units must be sold and produced? How do you guys maximum profit? Well, we got to figure out what type of function you guys have. And so this function right here, everybody should know the type of function. This is a quadratic, right? When you graph it, you get a graph like a parabola like this, concave down because of the negative. So how will you maximize it? It's this point at the very top, which we call the vertex. In order for you to find that point, that's the maximum value, you need to use the vertex formula, correct? Which goes something like this, minus b over 2a, minus 280, 2 times a, negative 0.4. So again, use your calculators. Let me see what my calculator tells me. 2 times 0.4. That gives me 0.8. 280 divided by 0.8. This gives me 350. So that vertex is going to be 350, comma, and then we just need to find that other value there for the vertex. To do that, since this is your x, 350, we plug it in. We plug it in into the function for x. And let me try to do that in my calculator again. Give me a second. So 350. That gives me, I'm going to write some numbers here when I plug in 350 in. Alright, minus 49,000 minus 24,000, it gives me 25,000. So if I plug in 350, it gives me 25,000. Alright, there we go. I found the vertex. All you have to do is the same thing, right? Find the vertex, minus b over 2a, and plug it into the function to get your y, your x and your y of the vertex. So now let's answer this problem. To maximize profit, how many units must be sold and produced? Well, what is the units? If you read the problem, it says here that x is the number of units produced and sold. So for A, the answer is 350 units must be produced and sold. And then your P of X is the profit. So that's going to be $25,000. Okay, you will make a maximum of $25,000 if you sell and produce 350 units. All right, for this part C, the 9,000, you're going to plug it in here for P of X, and then you're going to solve the problem. I recommend you guys use the quadratic formula to figure the answer to that problem. Okay, so I'll stop there on that problem. 16. Okay, domain and range. We all should know all of these functions. The first one, if you notice the x squared, therefore it's a quadratic. Quadratic problems, the graphs look like that. Therefore, the domain and range is all real numbers. And then the range is from negative 20. That's the lowest value that it goes. No, not actually. It's from 0 to infinity. And again, you guys can use your graphing utility to look at it. But we should all know these type of problems, right? This one, the second one, it's a natural log. The LNs are called natural logs. The graphs of those, they look like this. Okay, so from 0 to infinity is your domain, normally. and your range is all real numbers. All right, let's look at this third one. Those sticks between 2x plus 3, that's called an absolute value. It's an absolute value function. How does the graph look like? The graph looks like a V, similar to a quadratic. The domain is all real numbers, and the range is going to be from -8 all the way to infinity. All right. Number 16D. Again, you should be used to those type of problems. 4 to the power of x, or the exponent of x, those are called exponential functions. The graphs look like that. It grows quickly. Okay? Domain is all real numbers. Range is from 0 to infinity. All right. Let's move on this one. Let's do one of these. 17 or 18 are similar, so let's try one of these. Determine the sales at the end of the campaign. Let's see. At the end of the advertising campaign, the weekly sales declined. The weekly sales in dollars are modeled by the function y equals, where x is the number of weeks after the end of the campaign. So here, if you need to determine the sales at the end of the campaign, how many weeks have passed? 0, right? So we need to plug in 0 where? In the x. So -0.08 times 0 gives you a 0 there. 2 to the power of 0 is 1 times 12,000 gives you 12,000. There was 12,000 sales at the end of the campaign. $12,000 in sales. In 6 weeks, well, the 6, we're going to plug it in for x. We use calculators, and that's all we do. We use a calculator, and we plug it in and get a solution. Okay? So if you have any questions on how to use or how to plug it in the calculator, I can definitely help you with that. Just let me know. Does the model indicate the sales eventually reach 0? What do you guys think? Does it reach 0? Well, we know that the graph of something like this, it's an exponential. It goes like this. It's falling. But the asymptote is the x-axis, so it never actually reaches 0. It gets close to it. It hugs it. But since it's the asymptote, it never reaches it. So does the sales eventually reach $0? No. Because the x-axis is the asymptote, you guys can say that. Alrighty, so let's move on. Let's try a couple of these. Let's do B. So in order to solve, every time you have log, you have to use an exponential. But let's leave the log by itself first. So what I'm going to do is I'm going to subtract 4 from both sides. And then here the log is by itself. We want to change it now to an exponential. How do we do that? Well, the base. The base is 10. 10 to the power of 6 equals to x. 6 zeros. And that's your answer. All right, 1 million. Okay, let's try another one. Let's try, we can do D or E so that we can have 2 different problems so that you guys can see them. Let's go ahead and try, I guess, D. Okay, this is an exponential again. So if you have an exponential, we have to use logs. If you have logs, we have to use an exponential. Okay, so the very first thing, I'm gonna get rid of the 1200. To do that, I have to divide both sides by 1200. So in other words, essentially it's 3 divided by 12. That gives you 1/4 or 0.25. All right, here we go. We're ready to use logs now. So the easiest way I recommend, I guess, is placing logs in front of each of the side, the left and the right. And if you place a log in front of the left and the right, the exponent now becomes, it moves to the front. Okay, that's what logs are good for. So if I put a log on the left and I put a log on the right, such as this, what that does is the exponent goes to the front. And so now all I have to do is divide. Since I'm trying to solve for x, I'm going to divide by negative 0.1 to get rid of that one. And then I'm going to divide by log of 2 to get rid of the log of 2. Do it to the other side. And that will leave me x by itself. Plug all this in your calculator. You guys can do that. Log of 0.25, close your parentheses, divided by, put parentheses in here because there's two things in the bottom. There's a negative 0.1 and a log of 2, okay? And then plug it into your calculator. And then the answer should be, give me 1 second. It should be 20. Okay. Good. And then you guys can give the other ones a try. Let me know if you have any questions, guys. On these problems 20, we have to rewrite a logarithm as a single logarithm, compress it. So kind of like what we were talking on 19. Let's do 20a, the 2 in front of the log. We're going to go in reverse order. Now, the 2 doesn't go to the front of the log, it goes to the exponent because we're trying to compress it. The 5 goes to the top. And the 8 goes to the top. All right, when you guys have a plus sign, what that means is you're going to multiply x squared and y to the 5th. When you guys have a subtraction sign, that means it's division. And I've compressed a big log into a single log. All right, and now notice this one looks like either 21a or b, and you would work in the reverse order. This would be step number 1. This would be step number 2. Okay, you separated by adding them. I guess we can try one of these so that you guys can see it. So let's try 21a. ln of y squared, you're going to put a plus sign because we're multiplying, ln of e to the 3x, and then since we're dividing z3, you put a minus sign, ln of z cubed. All right, that's how we're now going to expand a logarithm. The 2 goes to the front. The 3x goes to the front. Now notice this is ln of e. ln of e is just 1, and so we're just left with a 3x in this case. And then on this third term, the 3 goes to the front. And that's as much as we can do. We've expanded. For 22, 23, they're similar. What we're going to do on 22 and 23, let's pick 22, I guess. We need a formula. Let's see. All right. Okay, so the compound interest formula, correct? So you should know this formula. You should have it somewhere written down. Make sure you study it. If we're going to do an investment, buy a car, buy a house, put money away, we use this formula here. So your principal is the $9,000. The rate is 5.5% as a decimal though. It would be 0.055. You move decimal twice to the left. Divided by the number of times compounded in a year. In this case, it says monthly, so there's 12 months in a year. Put a 12 there. And for N, you put 12, and then for T, how many years? It says somewhere. Oh, we're writing the equation, so we're writing the equation first. I didn't read fully the problem. So this would be the equation for A. And then now it says for B, 4 years. So in here we would put 4 years. And calculate all these numbers in your calculator, and it'll give you an amount. Okay? That's what we need to do for 22. Now, for 22C, it says, when will it double? So if the investment was 9,000, doubling means that the A should be 18,000. Okay, and so you do some algebra here to figure out the value of t. You're going to use logarithms. Let me put it over here. It was 18,000 equals 9,000. 1 plus the rate was 0.055 divided by 12t. So we're going to divide 9,000 to the other side. All right, 0.055 divided by 12. So it's an ugly number. So we'll just leave it as is since it's a big decimal. We won't try to reduce the inside of the parentheses. But if you guys remember, this is an exponential. In order to solve exponentials, you have to use logs. Place a log in front of the left side. Place a log in front of the right side. What does logs do? They bring exponents. The 12t brings it to the front. So this is the log that I placed in front of both sides. And again, if you want to figure out the value of t, all we have to do is divide by all of this. Divide by the 12 to get rid of it. And divide by the log of 1 plus 0.055 divided by 12. Divide it to the other side as well. All right, divide that and you're going to get the value of t. It will take whatever you get as an answer. I guess, let's see what it says. Put all that in the calculator, and approximately it takes 15.4 years to double from 9,000 to 18,000. Okay, and this would be the algebraic way of showing that. All right. Number 24, 25, similar. They're both exponent 3. So what we know about exponents 3 is a graph that looks something like this. And if it's a negative in the front, it would look like this. Okay, so all we have to do is describe some of these things. So state the degree. The degree is 3. The leading coefficient is a number in front, and it's a 3. Okay, so the degree is 3. This is the degree, and just the 3. And the leading coefficient is 3. Find all x's such that f of x equals 0. So we have to do, for problem B, we have to do a little bit of algebra. I'll take you through some of the steps. You set it equal to 0. In order for you to solve, you have to factor by grouping. They both have a 3x squared in common. The second one, they both have a negative 12 in common. And so this will give you 3x squared minus 12 and x plus 6. Set them equal to 0, and you'll get your, in this case, you'll get 3 solutions, okay? So this is what you would be doing for 24B. It's factor by grouping. C, describe the end behavior. On the left side, the graph is going down. So we're doing 24. C, as x goes to negative infinity to the left, then f of x, the y's, go to negative infinity. They go down. Now let's go to the right. So what's happening on the right side of the graph? As x is going to the right to positive infinity, the y's are going up to positive infinity. Okay, that's describing the end behavior. Graph, we don't need to really graph. We already know what they look like. We can plug in some of the solutions there that we put, and then just do a rough draft. That's all they want here. How many turning points? It has 2 turning points, right? It goes up, and then it goes down. So that's 1 turning point, and then it's going down, and then goes up. 2 turning points. So 2. How many inflection points? This is always the degree. The degree is 3 minus 2. So this is just 1. Okay, so the degree is 3. Always from the degree, subtract 2, and you get your inflection points. At what point does the local maximum occur? And round your coordinates to 1 decimal place. So that you can just approximate. And you can graph, like I said, on decimals if you would like, and you would be fine. Okay, just approximate more or less to 1 decimal place. Okay, 26. All of these are about factoring. So it shouldn't be too bad. We can try maybe one of these. Let's try C, I guess. We can factor an x squared. And in order for you to factor this, you can use the AC method, or you guys can use the quadratic formula. Okay, so you've been doing that. I think I'll let you guys work on that one. 27. What we have to do, we'll take a pick. The domain is all real numbers except what makes the denominator 0. So the denominator, x squared plus 7x plus 10, I'm going to factor it. And what makes it 0, it's a -5 and a -2. So your domain is all real numbers except -5 and -2. Vertical asymptotes. These same numbers are your vertical asymptotes. Horizontal asymptotes is if the numerator is smaller, the degree is 1, is bigger than the degree of the denominator, then y equals 0 is your horizontal asymptote. All right. 28 and 29 are two problems that we just finished doing, so I think that's fresh on your minds. I'll let you guys finish those two problems. And let me know if you guys have any questions. I'll be happy to help you guys out.